All right, last question of the packet. So here we have another spherical symmetry. Oops. But now it gets interesting because this is not a conductor. It is a charge with uniform volumetric charge density. So if there are charges in here, then that means, oops, those are some pluses, then that means that this is an insulator, not a conductor, right? So I'll just remind you, rho is that, whatever total Q, sometimes you just want to write like Q total so you're really, really clear about what you're talking about, and then the V total. And just to get our brains going on this, if we want to just say that it has a positive charge Q as the total, and sort of traditionally we call the radius of the actual object capital R. So we can just sort of hold this in our back pocket as we're thinking about things. All right, so let's start things up. Let's do the outside first. I wonder if you already know the answer. Do you? I hope so. So we're going to do this. All right, so outside we have, this is a sphere again, so our area is 4 pi r squared. Our total enclosed charge is the entire sphere. So we called that Q. Okay, and over epsilon naught. Boom. So, right, you knew this. It was just going to look like a point charge. Now, if we're, let's be careful. It says it has a uniform volumetric charge density, rho. Probably to be more specific, it would also have to tell you that the radius is r. So let's just, to be good, write Q. It's 4/3 pi r cubed rho. Yeah? And so RE is 4/3 pi r cubed rho, that's our Q, divided by 4 pi epsilon naught little r squared. So what do we get? Our pi's go away, our 4's go away, so we get a 3 down here. Still have an epsilon naught, we have a little r squared, and what do we have up top left? We have rho r cubed. Okay, so that's another way of writing it. Cool, so that's inside. But what's really important is that E goes as 1 over r squared, right? It looks like a point charge. And then we just needed to be careful about how we're writing our things in terms of variables that we've been given. So that's cool. Okay, so let's do the inside now. So our Gaussian surface is going to be on the inside, has a radius r. So, the enclosed charge that we're going to be interested in is going to be what's contained in that volume. So we get our 4 pi r squared, we get our epsilon naught. So really, the only trick here is saying, all right, how do I figure out that charge that's enclosed? Rho is Q over, Q total over V total, which is Q enclosed over V enclosed. This is for uniform densities, of course. And so we get this ratio where we're looking for our, and don't ask me why I go back and forth between capital Q and big Q. Or capital Q and big Q, capital Q and little q. I really have no rhyme or reason about it. But the idea is that we get, some factor some fraction of our total charge, right, is what's enclosed in that sphere. And that fraction is given by the ratio of the volumes. So Planck is, right, I think this sphere we decided had a positive charge Q, and so the enclosed volume is with our little r for the Gaussian surface, and our total volume is that. So we get that total Q, and then I think in one of the other videos I mentioned that when we do this ratio of volumes thing for spheres, we get this ratio of r cubes. Okay. So 4 pi r squared, and this is Q, and this is r cubed, and epsilon naught, and r cubed. All right, so what do we get? We get a 4 pi epsilon naught r cubed down here. We have the r squared on the left and an r cubed on the right. So we get this Q, and then there it is, right? This whole thing, that's a constant. So really, that is what really matters. So E is proportional to R. So if we want to do this graph, this is a really, really common thing to do. It goes as R, and then it goes as 1 over R squared. You probably want to make sure that that spot is actually the same value. Sure. Inside, what did we have? We had E is Q over 4 pi epsilon naught R cubed, and then times R, that was E in, and then E out, of course, is 4 pi epsilon naught down here, R squared there, and then that was Q. So my question is, what is this at a value of R, right? Because what am I saying is that at the location where I'm looking, where it's at the radius of the sphere, that's what I'm evaluating here. So it's Q capital R 4 pi epsilon naught R cubed. So that's Q over 4 pi epsilon naught R squared. And so obviously E outside at capital R is the same thing. So check that spot is, by the way, guys, sometimes we use epsilon for the 1 over 4 pi epsilon naught. Sometimes we just do KQ over R squared. You should hopefully be comfortable at this point going back and forth. All right.